All right, what do we have for this first one here? Okay, so observed. He observed the cathode ray tube. And what was it that he observed? So he saw something. From one side to the other side in a vacuum tube. So when he made that jump, he saw it because it so something was jumping across the tube, and as it jumped across the tube, it was interacting with the glow-in-the-dark paint, causing the paint to glow in the light, whatever. From that, he realized something is coming off of the atom. So what things did he learn that turned out to be true? Okay, atom has parts, charged parts, and one more thing. No, he doesn't know that. One of those parts can come off. He realizes that this is a charged particle that's leaving the atom, and he knew that because he used a magnetic and an electric field to deflect its motion across the vacuum tube. So he knew it was charged, and he knew that there must be another charge that's equal and opposite of it because the thing itself didn't have a charge on it. If you just grab an object, it's obviously not charged, but he's witnessing some charged particle coming off. All right, so based on chemical reactions on the actions of electrons, write down a single replacement reaction. Tell me what happened here. Okay, so let's do, magnesium solid plus copper chloride aqueous. On the other side here we get a copper solid and a magnesium chloride that's aqueous. So what happened? The copper gained electrons that it was given to it by the magnesium. So this chemical reaction is really just about the electrons getting transferred from one atom to another. What was important about this relationship between Thompson and Rutherford? Thompson didn't believe that. Not initially. His theory was that plum pudding model, right? But that's not what I'm asking about. I'm not talking about their theories. I'm asking about their relationship. They're friendly. Not a former student. The word I would use for this is super important. Why was the fact that their relationship was collegial important? Criticism? Z, what else we got here? What? All right. So the important part was Thompson didn't tell him to go to hell. He said, let's work on this. Let's make the model of the atom better. Let's know what's really going on. Not something that happens a lot because people's egos get in the way. But Thompson and Rutherford were both not as interested in ego so much as interested in just what science was about. That was what was important. Can anybody give me an example of two people who didn't have a collegial relationship and stymied American and human development for decades and decades? Nikola Tesla and Thomas Edison. Edison gets pumped up in the United States as this like incredibly important, benevolent person, and really he's just an ass. A smart one, and he got some stuff right, but really he took other people's ideas, furthered them along, passed them off on his own, and then made lots of money off them. And when anybody went against him, he tried to squash them. So what is it that Edison comes up with? The light bulb? Okay, but runs off of what? What kind of electricity? Runs off of direct current, the same kind of electricity that batteries run off of. What comes out of that wall socket? Alternating current. So who wins this battle? Tesla. Alternating current is a much better form of electricity. It's easier to work with. It's a hell of a lot less dangerous. We don't usually think about DC being dangerous because our exposure to DC is like a 1.5 volt battery or a 12 volt battery, or some small amount, and this seems much more dangerous because it's 110 volts or 220 volts. But in reality, Tesla's version was immensely better. If the relationship would have been the same with them as it was with Thompson and Rutherford, we would have had cell phones. We never would have built telephone poles because we never would have had lines. We wouldn't have needed them, because that's how far advanced Tesla was into electronic theory and wave theories. So it's just frustrating that we can't just help each other out and move further along. These people have to be very prideful of their work. Taking constructive criticism isn't something that happens all that often. Want to explain this one here about column 1? All those metals in that column are trying to give away 1 electron. Even the hydrogen tries to give away 1 electron if it's in the right conditions. The last one? Tell me about fluorine's state when its oxidation state is 0. Okay, so when it's 0, we're talking When it's -1, it's ion. Anything else? That's what's going on, right? When I become -1, it's because I still have my 9 protons because I'm fluorine, but now I have 10 electrons. That's why I have a -1 charge. So all of this is about electrons, and that's what all this chemistry stuff is about anyway. Transferring electrons, sharing electrons, doing something with electrons. Whatever the electrons are doing, that's the important part about chemistry.